రెడ్డి జూనియర్ కాలేజ్ నిజమైన విద్యకు నిలువెత్తు సాక్ష్యం. 20 ఎకరాల సువిశాల ప్రాంగణంలో కళాత్మక నిర్మాణాలతో స్వచ్ఛమైన ప్రకృతి ఒడిలో ఆత్మీయతను ఆస్వాదిస్తూ విద్యా సౌరభాలు వెదజల్లుతోన్న చదువుల నిలయం బీరం శ్రీధర్ రెడ్డి జూనియర్ కాలేజ్. క్రమశిక్షణకు మారుపేరుగా సంస్కారం, నిబద్ధత కలిగిన బోధనతో పాటు మానసిక, భౌతిక వికాసం కోసం సువిశాల ఆట స్థలంలో వ్యాయామం, యోగా, వాలీబాల్, త్రోబాల్, క్రికెట్ మరియు ఖోఖో లాంటి ఆటలు రోజువారీ టైం టేబుల్లో భాగం చేయడం బీరం శ్రీధర్ రెడ్డి జూనియర్ కాలేజీకి మాత్రమే సాధ్యం. బాలబాలికలకు ప్రత్యేక హాస్టల్ వసతితో రుచికరమైన పౌష్టికాహారం, 24 గంటలు అందుబాటులో ఉండే సీనియర్ లెక్చరర్స్, విద్యార్థుల మెదడుకు పదును పెట్టే ఫిజిక్స్ ల్యాబ్, కెమిస్ట్రీ ల్యాబ్, బొటనీ ల్యాబ్ మరియు జువాలజీ ల్యాబులు, నీట్, జేఈఈ మెయిన్స్ మరియు జేఈఈ అడ్వాన్స్డ్ పోటీ పరీక్షలకు సన్నద్ధపరిచే విద్యా ప్రణాళికలతో బీరం సుబ్బారెడ్డి గారి ఆధ్వర్యంలో, బీరం శ్రీకాంత్ రెడ్డి పర్యవేక్షణలో అమ్మ లాలన, నాన్న పాలన, గురువుల బోధన కలిగిన త్రివేణి సంగమ సమాహారమే బీరం శ్రీధర్ రెడ్డి జూనియర్ కాలేజ్. అడ్మిషన్లు ప్రారంభమైనవి. సంప్రదించండి. బీరం శ్రీధర్ రెడ్డి జూనియర్ కాలేజ్, బీరం శ్రీధర్ రెడ్డి నగర్, NH40 రోడ్, ఖాజీపేట్, కడప. సెల్ నంబర్ 7036666777. జూనియర్ కాలేజ్ నిజమైన విద్యకు నిలువెత్తు సాక్ష్యం. 20 ఎకరాల సువిశాల ప్రాంగణంలో కళాత్మక నిర్మాణాలతో స్వచ్ఛమైన ప్రకృతి ఒడిలో ఆత్మీయతను ఆస్వాదిస్తూ విద్యా సౌరభాలు వెదజల్లుతోన్న చదువుల నిలయం బీరం శ్రీధర్ రెడ్డి జూనియర్ కాలేజ్. క్రమశిక్షణకు మారుపేరుగా సంస్కారం, నిబద్ధత కలిగిన బోధనతో పాటు మానసిక, భౌతిక వికాసం కోసం సువిశాల ఆట స్థలంలో వ్యాయామం, యోగా, వాలీబాల్, త్రోబాల్, క్రికెట్ మరియు ఖోఖో లాంటి ఆటలు రోజువారీ టైం టేబుల్లో భాగం చేయడం బీరం శ్రీధర్ రెడ్డి జూనియర్ కాలేజీకి మాత్రమే సాధ్యం. బాలబాలికలకు ప్రత్యేక హాస్టల్ వసతితో రుచికరమైన పౌష్టికాహారం, 24 గంటలు అందుబాటులో ఉండే సీనియర్
Good evening, everyone. So you can chat me, you can send messages. Dipti, good evening. Good evening, good evening. Nare, good evening. Simon, Geetika, good evening. So all of you able to hear me? Voice is clear, right? Sai, good evening. Krishna, good evening. Nahi, good evening. Yes. Okay. So let me know if you have any audio problems. Akhil, okay? Good. Very good. Okay, so in the last class we discussed about some refractive index concept. At the same time, as the light goes from rarer to denser and denser to rarer, how it will behave, that we have seen. Okay, today okay. So we discussed even Snell's law also, how refractive index, okay, linked with the angle of refraction or angle of incidence also we have seen in the last class. So hope all of you note it down, right, and revised also. Today what we do is we will go a little beyond. Okay, we don't go with any mathematics, but we will try to get an overall view. Okay, how ray will travel when variable refractive index is given. Okay, so what is the concept? Variable refractive index. Maybe this is a new word for you. Let me know in the chat box how many of you feel or how many of you felt a new word of variable refractive index. Have you heard of variable refractive index before? No. Okay, Sai. Any other? Anyone knows what is the variable refractive index? Okay, Samya. Vignesh, no. Vignesh, yes. Vignesh, no. Okay. New concept? Okay, good. So that means you are going to learn some new thing today. Okay, Vivekananda? Yes. Very good. So all of you be little attentive. Okay, na? Then we will discuss what is the variable refractive index. See, in physics, most of the concepts you will find variable concept. What is the meaning of variable? Variable means changes. Okay, na? Variable means which will change. So I think you come across two terms. One is called as constant in mathematics. Other one is called as variable in mathematics. Okay, na? So these are the terms of mathematics, mathematical terms only. One is constant. 2 is a constant. Okay, 2 value does not change. So 2 is a constant. X is variable. Am I right or not? I think this is the most common or most known concept to you, right? X is variable because we can take x value anything. I'll take 2. You will take 3. Somebody will take the 4. So like that, as I mean, x value you can choose of your choice. So that's why x is called as variable. Right? 2 is constant. Right? These are the two words of mathematics. Now same wording I'm using here. Variable means changes. Okay, variable refractive index. That means the refractive index keep on changes. That's called as variable refractive index. Okay, so I think you got some idea about variable refractive index terminology. How many of you understood this variable refractive index? Refractive index keep on changes as you move from one point to other point. As you move from one point to other point. All of you name properly, name it. Okay, please don't put your short names. Understood? One medium to other. Yes. I'm unable to see your name.
Dipti.
Dipti. Yeah. Partly Dipti, very good. Nice. Okay, so let us get into the concept of variable refractive index. But here a lot of mathematics is there. That mathematics you will learn in while you come into the 11th and 12th standard. But I try to give you a basic idea related to ray. What will happen when it is traveling inside the medium which is having the variable refractive index. Let us say that this is the one medium. This is completely one medium. Okay. This is completely one medium. But this entire medium is not having the same refractive index. The refractive index keep on changes. Let us say this is the one layer. Okay, this is the other layer. This is the some other layer. Like that, we can divide the entire medium into layers. It's something like I don't know how many of you ate the sandwich concept. bread will be there. After that, some feeding will be there, some filling will be there. Again, bread will be there, right? So something like that. Yeah, burger is a good example, Dipti. Thank you. Burger bun, again some fillings, again a bun. So something like a layer, cheese, mayonnaise, everything you keep, no? You love to eat it, right? Okay, so it's something like even also dosa. On dosa, you keep some curry, and again you fold it, then it will become something like a layer part, layer concept. Okay, layer by layer. Imagine layer by layer. And here, let us say that refractive index increases as we go deep. Okay, now I wrote some terminology here. Again, try to understand this part. Refractive index increases as we go deep. What is the meaning of it? The meaning is this is the top, let us say, this is the bottom. Understood? For medium, become denser. Very good, nice. Dipti, very good. Correct. As you go from this point, this is the top, this is the bottom. Let us say you can take like a lake. This is one lake. As you go deeper, what happens to refractive index? Refractive index is increasing. As Dipti said, refractive index increasing means it will become more denser. Okay, na? In general, it will become more denser. But I told you there is no relation between refractive index and density. Dipti, you are there in the last class? I told that there is no relation between the refractive index and density, but most of the times we take. No problem with that. In general, we can choose. Okay? So as we go deeper, what happens to refractive index is increasing. Now let us say that there is a one light ray incident. Then the question is, what is the path followed by the ray? What is the path followed by the ray? The ray bends towards the normal, very good. If you place air to vacuum, it decreases. Place air to vacuum. What is the meaning of vacuum? Air to place. Place the air to vacuum. You want to keep the vacuum in terms of air, in the place of air. Side towards normal, correct. Yes. Who is this? K? Santosha?
Yes.
Sandhya towards normal, correct. So as the ray is going from direct to denser, the ray reflects towards the normal. Don't go for reflection now. Reflection we do later. Okay, now we are only discussing about refraction. Got it? Deep it moves to near to normal. Yes, Jignesh, very good. Nice idea. Perfect. As we go inside, it will bend towards the normal more and more. Okay, now? Then this is the normal, let us say. This is the normal, it will bend towards the normal. Again, it has to bend towards the normal. Again, it has to bend towards the normal. That means it will take some curved path, something like this. Understood? It will take curved path. I think maybe it is very difficult to see the diagram over here, bend towards the normal, perfect, because see, refractive index is increasing, no? That means ray is always treated as it is moving from rarer medium to denser medium. What are the factors responsible for bending of light? Dipti, this is refraction, already we discussed, no? Because of change in refractive index, because of change in light speed. Dipti, okay, because of change in light speed, what happens? Ray will bend towards the normal. Now, okay, same thing. That we discussed in last class. In the last class flow, we are doing. So this I am discussing furthermore. Okay, this is the one layer. That is this is the other layer. This is the third layer. Now I am taking the example of 3 layers. I will explain and then we generalize. All of you understand here? I am taking the combination of 3 layers. First, we will see that exactly atmospheric refraction. Very good, perfect. Okay. What I am discussing is something like a refraction when light ray passes through atmosphere. Because in the atmosphere, entire atmosphere doesn't have a same refractive index, right? As you move close to Earth, the refractive index varies. Usually, it will increase. Usually, okay, because atmosphere is most unstable medium. It won't be same. It keep on fluctuating. Okay. So if I take one ray, one ray incidented. Okay, na? This will have the less refractive index. This will have the more refractive index. This will have more than that. This will have more than that. As you go down, what happens to refractive index? Refractive index is increasing. As you go deeper, refractive index is increasing. Then it will bend towards the normal. Let us say this is bent towards the normal. They bend. Again, you draw a one normal here. Again, it will bend towards the normal. Okay, again you draw a normal here. Again, it will bend towards the normal. That means what is the ray? Suppose if you are taking this thickness is less. Becoming denser. Exactly. As you very close to Earth, it will become denser. As you go close to Earth, then it will become denser. No doubt. Okay, refractive index will increase. Usually. Good, Dipti. Correct. Dipti, perfect. Okay, na? So like this, as the refractive index is increasing, the ray will bend towards the normal and normal. Then what happens as refractive index is increasing in the medium? What is the ray? What is the path of the ray? The path of the ray will be, it will be curved one. The ray will go in a curved path. It will bend towards the normal. Okay, so you see this part. All of you understood? Any doubt in the path of ray? If you have any doubt, let me know. Very good, Dipti. Understood? Nice. Any other? So you can copy this. If you understood, clear. Mahi, very good. Padma, very good. Gitika, very good. Write it down. Now you try. You write down. I tell you other place. You will try it. You can draw the ray diagram. Dipti, thank you. If you are understanding, it's good. No problem. Okay. If you don't understand, let me know. I try to explain in other way. Okay. Absolutely no problem. We are having very good time. You can learn so many things. Okay. Note it down. We will go with another page so that we will get more command on this concept. If there are mediums, we can say that right follow. Light follow, yes. Who is this? C? Vishnuvardhan. Follow parabolic path, yes. We should not say parabolic path. It's a curved path, that is enough. Parabolic means it has to follow some particular equation, y is equal to x square. Vishnu, okay? Vishnu, that is a special case you are saying. Sai, refractive index may change because of density factors also. So as you go deeper, usually in what we say that in lakes, maybe in sea, in atmosphere, like as you go deeper, what happens? At the bottom you will find more density. Okay, now more dense means more molecules. Molecules are very closely packed. As molecules are closely packed, that might have refractive index might change. Okay, Sai? Okay. Vishnu, you understood that parabolic path is a particular one. Y is equal to x square phenomenon. So that's why I didn't say that parabolic. Parabolic also can happen. So instead of parabolic, it is better to say it follows the curved path. Light follows. Okay, I'll write on that also. Light follows curved path. Clear? Okay, Vishnu. Okay, Vishnu. Sai, you understood that? Okay, good. Sai, tell me if you have it. Completed. Here, what I have given, this is the path of light while refractive index is increasing as you go deeper. As you go deeper and deeper, refractive index values keep on increasing. Okay? Now, we will try. Suppose this is the medium where refractive index is. Okay, na? Refractive index decreases as we go deep. Okay, this is the top and this is the bottom. Top and bottom. As you go down, what happens to the refractive index? Refractive index decreases. Then now try to draw what is the path of light follows inside the medium. Suppose this angle is theta. The speed decreases. The speed decreases, what will happen? Refractive index has to increase. But here I have given refractive index decreases. That means speed will increase. Lakshmi, away from the normal, correct. Lakshmi, perfect. Lakshmi, mu value decreases. Bend, no, Navya, wait. Navya, you verify your idea again. Navya, that is wrong. It won't bend towards the normal. It will bend away from the normal. Once verified. As we go deeper, refractive index decreases. All of you try it. Exactly. Santosh, huh? K. Santosh? Geetika, correct. Sandhya, okay. Sandhya, correct. No, Dipti, correct. Dipti, perfect. As you go deeper, refractive index decreases. That means it's something like in rays traveling from denser medium to rarer medium. Okay. Angle increases, correct. If you are measuring the angle from the normal, it increases. Bends away from the normal, so I correct. Now all of you draw it. Draw the diagram. What is the curved path it will follow? All of you draw in your notebook what curved path it will follow. Okay. I am unable to see your notebooks because it is an online class. Okay. But hope you are doing sincerely. Okay. Sincerely, just not. Soumya, wait, I'll explain again. Don't worry. Soumya, I'll explain here. Then you can refer to previous one. Both will have the same logic. Logic will be same. No doubt. Soumya, okay? Now, as we go to what happens to mu value? Mu value decreases. That means this is one medium. Let us say this is another medium. This is the third medium. Here only. Okay, 3 layers I'm taking. I'm taking the 3 layers. Something like this. Let us say. These 3 layers I'm taking here. Imagine in that way. If I take the 3 layers, then what happens as you go deeper? What happens to refractive index? Decreases. Let us name it mu1, mu2, mu3. As you go deeper, refractive index decreases. That means mu1 is more than mu2, more than mu3. mu3 will be smaller. Azubai, you are very good and very good follower of means, reals, it seems. Very good. You practice the Kachavada and ultimately maybe Kachavada will help you. Okay. Jignesh, correct. Perfect. Okay, so as you go deeper, mu1, mu2, mu3, so refractive index keep on decreasing. Okay, mu1 is more than mu2, mu2 is more than mu3. Okay, suppose ray travels here, then it will bend away from the normal. That means what? It will have something like this. Okay, not exactly. Okay, maybe it should like an angle. Let us change it. Okay. So this is the normal, and this is the ray. As you hope you are able to see. Now it will bend away from the normal. Again, you will find a normal here. It will bend away from this. Okay. So again here it will bend away from the normal. So that means how the ray will travel. See, ray is traveling in this way. Ray is traveling in this way. That means ray travels something like this. Okay, this is the path of the ray. Nani, very good. Second person came up. Okay. So I think how many of your diagram is coincided with mine? Now diagrams are diagram coincided. How many of you tried? How many of you? Okay, Vishnu, Yashwant, your diagram is coincided. Very good. What about Vishnu? Sandhya, you got it. Very good. Nice, Sandhya. Rishta also got it. Very good. And any other? Vishnu, you got it? Who didn't understand? Did you understood how curve came? See once here. See, this is the angle of incidence. This is the angle of refraction. Okay, na? Ray will travel from denser medium to rarer medium. Ray travels from denser medium to rarer medium because as we go deep, mu value decreases. Okay, mu value decreases. So you find that logic. As you go deeper, suppose mu1, mu2, mu3, suppose 3 layers you are taking in the medium, 3 layers will have different refractive indices. As you go deep, what happens to refractive index? Decrease. Refractive index has to decrease as you go deeper. That's why mu3 is less than mu2. mu2 is less than mu1. As you go deep, mu value has to decrease. That's why I wrote one more relation here. See once. Okay? That means this is the normal, this is the ray. As ray is incident here, it will bend away from the normal. Again, it will bend away from the normal. Again, it will bend away from the normal. Which this angle is more than this angle. This angle is more than this angle. Okay, now angle of refraction is more than angle of incidence. You try to understand that logic. Exactly. Very good. Did it perfect. If you are drawing all these lines, then it will become a curve. Because you have to imagine these are very small. Don't think this much. Okay? That is the only, for understanding, I wrote a big diagram. But this is not a, you should not take the same dimensions. You have to take these lines are very close. These lines are very close. If I take the lines are very close, then it will form a curved path. Okay, Dipti, very good. Nice. Hope you all understood. Okay. All of it clear? So I'll give it 2 more diagrams. Try to solve, try to draw the path of the ray. Okay. Under this, anyone copying? Anyone copying? Let me know. So I'm going to rub it. Now it will help me. Okay. See, things won't be created. Okay, Lakshmi, very good. Part 2. At last, it will be 90. Part 2, very good. It's a good question. Part 2 was asking about, Part 2 is asking a very good question. That is, this angle is theta. Okay, this is completely medium. What Part 2 is asking, it will bend and finally it will become a straight line. Finally, it will become a straight line. Akhil, yes. Exactly, correct. Akhil, what takwa illa? Akhil,
Akhil, unmute.
Hello, sir.
Akhil,
Nothing, sir.
Okay. You don't doubt, no? You kept doubt, right?
That only, sir. If we go on to the mu decreases, what happens? He asked the question, sir.
Okay. So, whatever Partha was asking about this way. So the ray will be straight line. Okay, na? Then what is the angle of refraction finally? It will become 90 degree. This is the normal, let us say. If this is the normal, then angle of refraction will become 90 degree. Okay. Clear? So I'll give you one other thing, other example. Suppose there is a medium something like this. There is a medium in this type. This is the medium. Okay, now. Suppose that ray is incident something like this. So this is the normal. Angle is theta. Angle is theta. The ray is incidented in this way. Suppose as we go towards right, mu value increases. Mu increases as we go towards right. As we go towards right, okay, as you are moving towards right, then what happens? Mu value increases. Then what is the path of ray? Don't go for denser medium. Forget about that idea. Okay, na? There is no relation with the actual density and refractive index. Okay, na? So try to keep that denser medium idea, denser medium logic in your from your brain. Yeah, always think like it's a random medium or what is that? Denser medium. Okay, it's not completely denser medium. It is becoming denser or rarer, you have to see. Now, obviously, away from normal. No, try to draw the shape of light ray. Light ray will travel curved path. How that curve will be generated? Curve is downward, upward, something will be there. No? You try to draw that. Towards the normal, mu value increasing. As mu value increasing, it will become denser, rarer to denser concept. Light ray irregular, yes, correct. Towards English, correct. When towards the normal, correct. Dipti, correct. As you move from one point to other point, what will happen? It will be something like a rarer to denser medium. Downward parabola, okay. Side towards normal. Now see, as we go towards right, now you have to imagine these are the rays. Imagine rays are something like this. If you move from one point to other point, what happens to refractive index? Vishnu, what is the reverse? Reverse U shape, huh? You are saying reverse U shape. Okay. Curved bend towards the bottom part. I tell you Dipti way. That's called as convex and concave. So if you see from here, it is called as concave. If you see from here, it's called as convex. Convex from bottom, concave from the top. Convex from bottom, concave from the top. That also can use. Okay. So as you go from one part to other part, what happens? Mu value? Mu value increases. Mu value increases. Am I right? That means what will be the normal? This will be the normal. Normal should be perpendicular to medium boundary. It will bend towards the normal. That means something like this. Bend towards the normal. Again it will bend towards the normal. Again it will bend towards the normal. Like this. So the graph will be something like this. Or part of the ray will be something like this. And then after some time, what will happen? Exactly it will follow straight line. Because the angle of incidence will be 0. Okay? So if you want, I draw a big diagram. I am expanding this diagram. Okay? If I am expanding this diagram, it's something like this. These are the different mediums. Let us say this is mu1, mu2, mu3, mu4. mu1 is increasing. That means mu1 is less than mu2, less than mu3, less than mu4. All of you understanding that? Let me know if you have any doubt. Very good. Nice. Who is this? Dipti. Okay. Dipti, you got it? Huh? Very good. How many of you got the same curve? I'll explain again. Let me know how many of you got the same curve. Hemant, you got it? Hemant. Got it, very good. Parthu got it, very good. Vishnu, Jigneshwar, Sandhya, Sai, Madhvi. Vignesh, you got it, very good. Nice. Nice, very good. Okay, so as it is incident at an angle theta. This is the angle of incidence because this is one medium, this is other medium. Third medium, fourth medium. Then it will bend towards the normal, something like this. Angle should be less. Again, it will bend towards the normal. Okay, na? So then what is the angle of incidence here? See, angle of incidence keep on decreasing. See, if it is theta, then this will be theta 1, this will be theta 1, this will be theta 1. So keep on decreasing. Then theta 2 keep on decreasing. After some time, what will happen? The ray may heat perpendicular to medium boundary. Then it won't deviate. It will go straight. Yes, we can say Vishnu. Pakka we can say that. Okay, after what distance it will become straight. That also we can say. We can say. But for that, what we require? We require the function of refractive index. Refractive index function. Okay, we have to know that part. And then you have to apply the Snell's law. Same concept. Mu1 sin theta 1 is equal to mu2 sin theta 2 logic. Okay, that we can do. And we can find out the equation of ray also. Equation of ray also we can do it. But not now, we will do it. Okay, Vishnu. That takes little time, require mathematics and so on. Harish, wait, we'll go topic by topic because if I say every topic, it will be more confusing to the people who are attending the class. Yes, Padma. We can tell the medium also. Medium, what is the angle of incidence in that medium? That also we can do. We can do all the things. See, science has gone to so many levels. Okay, na? Only thing is that is in our what do you say that syllabus or not in our that mathematics related mathematics do we know or not? It all depends on those factors. Sometimes mathematics is very high level mathematics will be there. Yes, Dipti, correct. High level of mathematics will be there, which we are unable to understand or unable to know those things. So that type of things we eliminate. We remove that part. Harish, tell me what is your doubt? Harish, unmute cheyna. Unmute chestuna nee doubt enti.
Harish, unmute na. Harish.
Harish, unmute yourself first. Value for diamond refraction. So that you have to refer the notes at Google. Google is the best part. Okay? Because it is very difficult to remember all the values. Even diamonds also, there will be so many types of diamonds. Different refractive indices will be there. Diamond is not like a single entity. Harish, okay? There are so many different diamonds. No? If the I can say one thing. If refractive index is more and more, that cost is like anything. Cost of the diamond. Okay? Cost of the diamond can be decided by using refractive index. Harish, okay? But values is a statistical thing that you have to refer the book and nobody will ask you value. And no need to remember the values. You have to remember some constant like G 9.8. Okay? So those things. Yes, Sanjay, it will go straight line. After traveling some distance, it will go straight line. That one I draw. This will be straight path. Straight line. Straight line path. It will have curve for some distance. This is a curve path. Okay. Dipti, every day you are looking at sun, no? You are looking at the sun apparent position or sun, you are looking, moon apparent position you are looking, stars, twinkling of stars because of variable refractive index only. It keep on atmosphere refractive index keep on fluctuating. Because of that, you will see some twinkling of star nature. Yes, okay. Even because of this variable refractive index only, usually you see that mirage concept. Last class also I told. You will see the water layer on a road when you are moving on very hot days. For astronauts, there is no atmosphere. No? They will be in vacuum. There is no question of refraction there. For astronauts, it's a plain thing. It's a different story. They will be in other world. For rocket launching, refractive index is not an issue, but atmospheric conditions are an issue. You have to see the atmospheric conditions, not the refractive index. Okay, Dipti, understood? Again, tell me. Again. Maybe I'm not having an idea because numbers. I'm having very poor memory of numbers. Okay. Because no need to remember the numbers. Nobody will ask you numbers for your 11th or 12th standard exams. What is the density of some other, let us say, oil, kerosene density? Who will remember those things? No need. They will give the data. In the question, they will give the data. We have to use the data. Okay. Dipti, by using formula, which formula you will use? For diamond refractive index formula is there? No. You have to do experiment. There are some other instruments to calculate the refractive index of diamond. I think if you have spectacles, then you will come to know that what is the refractive index of your spectacle. Spectacle, they will use the glasses now. There, some refractive index will be there. If refractive index is higher, then cost also will be higher. I don't know whether you observed or not. Okay, very good. If refractive index is more, then your glasses, whatever you are wearing, no eyeglasses, that will have thickness, less thickness. For refractive index more, you will have fine thickness is less. No need to keep the thick glasses. If you are having the high value of sight. Akil, okay? So don't worry about any number. They will give you a number. So happily you have to solve the question, not apply the physics. That's enough. Okay. Now the question is, suppose this is the denser medium. Mu D I am taking. This is the rarer medium, mu R. So now I am taking the only two mediums, no variable refractive index. I am taking the purely two refractive indices. One is denser medium, other one is rarer medium. Clear? Two mediums I am taking. Below is denser medium, above is rarer medium. Okay. Now let us say that if a ray is incident from the denser medium to rarer medium, this is the normal. Then angle of incidence is I. I is the angle of incidence. Then how the ray will travel? How the ray travels? All of you know. Tell me. Ray is going from denser to rarer. Away from the normal. Very good. Perfect. Away from the normal, something like this. Then what is the angle of refraction? Can you say R? Angle of refraction is R. Then what is the relation between I and R? What is the relation between I and R? Dipti, what is the same? Bend away from the normal. Huh? Bend away from the normal, you are seeing same, right? Yes, correct. Correct, Akhil. Perfect. I is less than R. R is having the more value, I is having the less value. We know that by Snell's law. Already last class we have done. Snell's law, what I write down? Refractive index into sine of angle. Refractive index into sine of angle is constant. So refractive index mu d. Refractive index is mu d. What the angle is? I. Then mu d into sine I is equal to what is the refractive index here? Mu r. What is the angle? R. Then mu r into sine r. I think all of you know this part, right? This is the Snell's law what we discussed in the last class. Clear? All of you okay? Now the question is, suppose I am increasing the I value. Means instead of light like this, now I am incidenting the light in this way. So angle of incidence is what happening? Angle of incidence is increased. I value increases. Then what happens to R value? R value will increase or decrease? If I increase I value, what happens to R value? Increase or decrease? Dipti, correct? Good answer. J Balaya, which decreases. Very good fan of Balaya. Very good, nice. You follow him. Okay. He dedicatedly works and goes to movie. Okay. He will go on time to shoot. Okay. Now he acts very well. So if you are following the Balaya, please follow sincerely the studies also. Okay. Timely attending the class, timely reading and all. Okay. Now we have Vishnu, perfect increases. But it does not increase. As I will increase, R value also increases. Proportionality. It follows the proportionality. Please name properly, don't do all these things. Okay, na? You show your fanism in the cinema hall, not here. No problem. Okay? You better stay at home and go to the videos of Bali. No issue. Okay, as I value increases, R value also increases. Okay, as I value increases, R value also increases because these are constant values. Mu d and mu r does not change. Mu d and mu r does not change. If left side increases, right side also increases. Raju, y increases, R value. That's what I'm saying. Raju, I'm explaining that part of it. See, left side one numbers are there, right side also other numbers are there. Right? Both should be equal. Left side values should be equal with the right side values. Raju, are you listening? Left side value should be equal to right side values. Mu d and mu r value does not change. Mu d and mu r remain same. If I value increases, sin I value also increases. That I discussed in the last class. If theta increases, okay, sin theta increase. Because we are talking about 0 to 90 angles. If theta increases, sin theta also increases. If sin I increases, I value increases. Or I value increases, sin I value also increases. If left side increases, right side also increases, no? Left side increase, right side also increase. Then only they will be equal. Otherwise, they won't be equal. Raju understood? Very good. Nice. I think all of you understood. If left side value is increasing, right side value has to increase. As I value increasing, R value increases. Then I value increases, R value increases. Okay? That means if this is the new ray of light, then this will be the ray. Okay? No? You will find increased R value. R value increases. If it is I dash, that will be R dash. As I value increases, R value also increases. So, at a particular angle of incidence, so again, same diagram I'm drawing here. This is the mu d, this is your tensile medium, radial medium, and this is the normal. Okay, at a particular angle of incidence, the ray will travel. Ray can travel something like this. With angle of refraction is 90 degrees. That is possible, no? I is directly proportional to R. Yes, or you can say not directly proportional, proportional you can say. Exactly 90 degrees. Now we are talking about critical angle. Very good. Thank you. Just I want to say that how many of you will identify. I am talking about critical angle and what is the concept I am teaching? Anyone identify? Dipti, very good. Any other? Okay, Vishnu, correct. Raju, think again. What is the concept I am teaching? TIR, yes, Gitika, correct. It's total internal reflection I am talking about. Okay, Raju, clear? It's not. It's a part of refraction only. But I am going with a special case where at a particular angle of incidence, you will find the ray travels. Dipti, mirrors is a different concept. We discussed that. I mean, part of TIR only we'll discuss that. Okay, later we discuss. Yeah. So, at a particular angle of incidence, ray can travel along the medium boundary. This we call it as what? Grazing refraction. Ray grazes the boundary. Grazing means along the boundary it is going. Along the medium surface it will travel. Then there, what is the angle of refraction is 90. Then this angle we call it as the angle at which refracted ray travels along the boundary, that angle is called as critical angle. How many of you know critical angle? Usually we represent with theta c. Okay, now if anyone wants, you can copy this. I talk about critical angle. Very good, Tarani. Tarani, I think this is the first response from you this day, right? Raju, first year. Four-star questions. Yes, you can follow four-star questions. No problem. But why are you talking about first year intern? JT completed, very good. Raju, okay, no issue. IP is what this happens. IP is not a matter. Everybody is getting the marks nowadays. So it is always task to get a rank in JEE or NEET. Okay, that is a good thing. According to your rank, your college will be decided, your branch will be decided. Okay, where you have to study, that will be depending on what is the rank you are getting in competitive examinations. Where we can observe the total internal reflection. Diamond is the one thing where the light will be reflected. That's why it's more shining. Part 2, long term. First of all, we have to complete the things. No? Then we think about long term. Usually, long term is not suggestible thing. Whatever is there, you have to complete in your first and second year of intermediate. Vishnu critical angle is a defined factor. Your name is Vishnu, no? We should not call it some other thing. So similarly, we are talking about as a ray is traveling from one medium to another medium, which is simple refraction. That phenomenon is named as refraction. But when it comes to ray, it's traveling along the medium boundary, then it is called as what? Critical angle. It's a named one. Okay, particular phenomenon we name each other. Vishnu, you understood that? So that is refraction phenomena. This is the what? Critical angle phenomena. If your angle of incidence is more than critical angle, then it will be total internal reflection. Okay, it's something like a name. Different cases are named differently. Vishnu, okay? If it's not standard angle, it's called as critical angle. The value changes as refractive indices changes. Okay, I think all of you wrote down. Let me write down something, some formula related to this. Okay. So now we want to go with critical angle concept or critical angle value. Critical angle. So we write down with theta c. I think in your textbook also theta c is there. I don't know exactly. So what is the terminology they follow? Yes, correct again. Very good. I can correct. Okay, critical angle I am representing with theta c. Most of the books also follow the theta c. Yes, Scott. It only happens when it is moving from denser to rarer medium. It does not happen from rarer to denser. Rarer to denser bend towards the normal, no? Then how it will go along the medium boundary? How refraction, angle of refraction will become 90. That won't happen. Okay? So now this is the denser medium, this is the rarer medium. Let us say this is the normal and this is the angle of incidence. Critical angle. Angle of incidence is called as critical angle, where refracted ray is traveling along the medium boundary. Okay, critical angle is the angle of incidence. Critical angle is angle of incidence at which refracted ray grazes the medium boundary. What is the meaning of grazing? You understood that? Grazing meaning you understood? Grazes means moves along the boundary. No. Vivekananda, critical angle is one angle where you can identify whether TIR will happen or not. So stick to the class for 5 minutes, then I'll explain. Don't worry. Okay, na? Then what the angle of refraction is? Angle of refraction is 90. So this angle. With the normal, how much angle it will make? It will make 90. Now we'll apply the Snell's law. By Snell's law, what I can write down? By Snell's law, I can write down that okay, refractive index into sine of angle. Refractive index is how much? Mu d into sine of what is the angle? Theta c. Mu d into sine of theta c is equal to mu r into sine 90. See, refractive index is mu r, angle is 90. Mu r into sine 90. Okay, wait for that. I will explain. Critical angle is you should not do in that way. I tell you what to do. How you have to go with TIR with critical angle. Okay, all of you understood this equation? Refractive index into sine of angle in that medium is constant. What is the refractive index here? Mu d. What is the angle here? Theta c. What is the refractive index here? Mu r. What is the angle? Is 90. So mu d into sine theta c is sine 90. What is the sine 90 value is 1. Then mu d into sine theta c is equal to mu r. Then what is the sine theta c is equal to mu r by mu d. Then what is theta c is equal to sine inverse. Already I told sine inverse concept. Take the sine on the side. It will be sine inverse mu r by mu d. Clear? All of you understood? Critical angle is the least angle. Partner? No, not with that. It will be maximum angle for refraction, minimum angle for total internal reflection. Refractive index is equal to 1 by sine c. Obviously, no. Not refractive index, relative refractive index. That means mu r by mu d. That relative refractive index you have to do. 1 by sine theta c is equal to mu d by mu r. I think you are talking about air case. Dipti, tomorrow might be chemistry class. Okay, so I will be meeting you day after tomorrow. Okay, day after tomorrow we will meet. For air, suppose if you are taking the variable is air, then what the mu r value will become 1. So let us say this is the mu. Refractive index is mu. Most of the textbook follows like this. That's why that also I'm explaining. Then what the sine theta c I can write down? Sine theta c I can write down as mu r by mu d, right? Mu r by mu d 1 by mu. Then mu is equal to 1 by sine theta c. I think somebody has given something like this. Mu is equal to 1 by sine c, where c is critical angle. In textbook, Navya has given the same. In some textbooks, theta c, critical angle has given as c. Okay, simply c. That's why I'm writing as sine c. Okay, so write it down. We will discuss about total internal reflection in the next class. Okay, so we will solve some questions also, simple questions according to total internal reflection. You will see some other uses of total internal reflection also. Okay, you will understand better. But you should have the knowledge of critical angle. If you want, you can copy this. If any other doubt is there, you can ask me. Okay, Dipti. Very good. Thank you. Okay, so we'll be meeting. Vivekananda, what is this brilliance of diamond? Brilliance means what? What is it? Appearance, huh? Are you talking about appearance? Vivekananda, if you are talking about appearance, then it is shining. Okay, that's what I'm talking about. If it is shining, then TR is, you can say that TR is the 1 plus 1. Inside some internal reflection will happen and light comes out. That's why you'll find the rays shining out. Light goes inside, no, it will take several paths inside the diamond and comes out. Because of high refractive index, no, it will take more number of total internal reflections. Vivekananda correct, yes. Vivekananda perfect. Whatever you said, that is correct. Okay, so all of you go through this. Little read all the things at the same time. Your textbook also will follow it. Akhil on Friday. Today is what? Wednesday. Today is Wednesday, Thursday, and Friday. Yes, exactly. Akhil on Friday will meet. Okay, na? Bye everyone. Dipti, bye. Bye everyone. Good night. Okay, we'll meet on Friday. Thank you so much. Bye.
Chemistry, good evening, children. Tomorrow chemistry, please join the class for the time. Thank you.